All right, record is rolling. It's Wednesday, May 28th, so last day of school. Last time I'll see you guys here. Yeah, if you haven't turned your laptop in by now, just later in class you can. I want to do an activity with you guys here in the first few minutes. Okay? And then, yeah, it's been a really good class. Hope you guys have gotten a lot out of this class. So, yeah, I've enjoyed teaching you guys and hope you guys have a good summer and good future. All right, so, I know, your guys' AP exam was like right at the end of the 2 week AP grade period exam schedule. So of course we did review up until the day, and we only had a few days after that. I could really do stuff with you guys. But if I could tell you one more activity, I wanted to do an intro to statistics with you guys. Introduce you guys to things like what's a normal distribution bell curve, what's standard deviation, what's z-score. You guys have meter sticks. Well, we're going to do this activity so you guys can answer this question. Like what percentage of students in the school could be shorter than you or taller than you, just based on measurements from like again, have you guys measure your heights in centimeters using the meter sticks. Okay. You might say, oh, well, if I'm the tallest student in the class, wouldn't that be like 0% of people would be taller than me? And that might be just within our class, but can you actually take this data and actually get some wider idea of like the wider population, right? So it might be, depending on how the numbers land, okay, well, maybe I'm taller than 95% of people and I'm shorter than like the other 5%, right? It's something like that. So let's see. Oh, yeah, if we're talking about normal distribution, there are a lot of things that are normal, a lot of statistics that are normally distributed. And some that aren't, but we're gonna sort of make believe just as a simplification. Right, so, ooh, a minute. Did I think I put my ruler away. Here, sorry. I'm gonna use this as a makeshift ruler right here. Oh, take good. That's all right. Oh, yeah. Right, yeah. Right, just to have a straight line. Yeah, I'm cleaning up my classroom and a bunch of supplies away. Right. But let's say you polled, say, oh, I don't know, 1,000 people. Okay. And you said, what is your height to the nearest centimeter? And maybe make like a bar chart, or I think they call it a histogram. So I'm gonna put frequency on the vertical axis here. Okay. So now I'm not going to put any numbers here, but I just want you guys to see the overall shape, the big idea of what we're looking at. So let's say finally, out of the 1,000 people, you take the shortest measurement, whatever height that is in centimeters. Right? And there's only like a couple of those. So you got like for a short height, maybe there's not too many of them. Right? And you go 1 centimeter up. Okay, maybe there's a couple more of them. Right? And you go 1 centimeter up. Right? And there's a couple more of them. Right? And you keep going incremental, centimeter by centimeter. Okay? And then after you plot all these thousands of people, okay, maybe you get something that looks something kind of like this. Okay, it's not the exact, but okay, just an idea. Maybe you got one super tall guy over here, or something like that. Right? If you stand back and look at it, it might create sort of like a bell curve type shape. Right? Hang on, look at this phone call. Pause this. All right, so we are back recording here. Right, so to make this bell curve shape. Now, yeah, I'm using heights of people. Is this exactly normally distributed? Right, maybe not, but maybe a lot of other metrics could be. Right? By the way, one reason I want to be stats with you, this shows up all over the place in lots of different sciences. If you want to do any hard science, maybe you want to test like is some medication.
Have a good summer.
Yeah, thanks. You too. Does it work, say, versus a placebo, or maybe you're working for a consumer protection agency and want to know does is something you pull off the shelf? Is it like does it meet some health standard, right? Right. So this could apply to a lot of things, but now, if you look at the shape of this curve, like this bell curve, okay, it looks like most people are kind of average height, and down on this tail, there's like some small percentage that's kind of on the short end, and there's some percentage that's kind of on the tall end. You guys see it, right? And most people are kind of more in the middle, right? Now, there's a couple of numbers, just two numbers you can have that can exactly describe this whole bell curve. Okay, what do you think one of those numbers is that I'm referring to? Like, what could be like right here? Do you think? Like the average, like an average, right? Okay. Now, if it's truly a normal distribution, here I'm gonna spell this out. Normal distribution. Okay. then this average right here is the mean and also the median and also probably the mode, right? Which are three different kinds of averages, but they would all be the same for a normal distribution. You guys know the mean is if you add up all the numbers and then divide by the number there, you'll get like the average that way. That's the mean, right? You guys know that, right? The median is like the middle value, right? Which is really like one application that is really useful for, say, income, right? So if you have, say, like a bunch of people make like an average salary, let's say like $50,000 a year, and then like a millionaire walks in, it's like, well, that doesn't make everybody rich on average, which the mean would say, but not the median. Okay? Right? And then the mode is the most common occurring, which looks like, yeah, that would be the highest bar, so that would also be the average from that point of view. Right? So it's like, all right, so if I told you that like the average height, right? Okay, that tells you like how far right or left this bell curve is, right? But how about this? Like, what's the sort of variation? Right? Like, how wide or skinny is this bell curve? Right? Now, do you guys see the point where see like the middle of this curve looks like an upside down ball, but the tails look like right side up ball? You guys see that? Okay. And I bet some of you guys know, especially if you're taking calculus, what the name of this point is where it changes concavity. What's that called?
Inflection.
Yeah, inflection point. Yeah, inflection point. Okay. And it turns out that the distance from this average, from this mean median average to this inflection point, okay, has a name. It's called, does anybody know what it's called? Yeah, it's called standard deviation. Standard deviation. Okay. Now I'm going to use the character sigma to represent this, or S. I'll say S or sigma could be standard deviation. In stats, usually S is for like a smaller sample, and the sigma is for like wider population. I'm going to use this somewhat interchangeably. Okay. Mean, median, mode. You'll see either an X with a bar over it, like X bar, or a mu, and kind of similar to there, right? But if you just have these two numbers, if you know like what the average value is and for some data, and you know the standard deviation, that can tell you exactly where to plot the curve and how wide to make it, and boom, you got your normal distribution, right? Okay. Now, if you look at these questions I set here, because I want to kind of go down slow. Okay, so we talked about normal distribution. We talked about mean, median, mode. Okay? Now, there is actually a way to calculate standard deviation, and we're going to do one of those. Okay. The next set of questions, like z-score, z-table, and leads up to these questions, like where do you sort of fit in with this wider population, right? So, like, is your height like right here? If you're say on this bar, you'd be pretty tall, right? But you're taller than like what percentage of people, and you're shorter than what percentage of people. Right? So we're working towards the table there, right? So, there's only 5 of you guys in here. Now that actually works pretty well for this stats activity that I want to do with you guys, right? Now my other classes, I gave this whole packet of stats, and we took a few days to go over this. I'm doing a real short version of this with you guys, right? But I gave them like 5 dog heights, 5 people heights, and 5 cat heights, right? So we'd have people, cats, and dogs, right? And then I wanted to map like which curve is which. Now, you guys think about the sizes of these, like people, dogs, and house cats. Isn't it true that probably people are the tallest and cats are the smallest, right? But there's also a variability type. So maybe people have some variability. Right? Do dogs have a lot more variability than people? Right? You got little tiny dogs, you have big dogs, right? But what about house cats? Aren't all house cats sort of the same size, right? So with that in mind, which curve do you think matches which? Like, what do you think this curve right in the middle would be?
Dogs.
It is dogs. It is dogs, right? Because dogs are taller than cats, but shorter than people. So it would have to be the middle curve. But also see how it's like really, really spread out compared to the other curves. It has more variability. Okay? Oh, by the way, all these curves have the same area underneath them because they each represent 100% of their respective population. So like if you turn this into a big old bar chart right here, right, for dogs, right? You got short dogs over here, you got tall dogs over here, you got medium dogs in the middle. There's a lot of variability. Okay. What do you think this curve is on the right? Yeah, this is people right here, right? Which tallest on average. That's why it's the curve is furthest to the right. Okay. But there's less variability, hence it's skinnier. That also makes it taller curve because the area under the curve is the same because it represents 100% of its respective population. Maybe it's like 1,000 dogs here, 1,000 people here, and then this would have to be what? Yeah, cats. right? Maybe there's 1,000 cats, right? And they're all sort of the same size, right? So there's almost no variability. Again, there's 1,000 cats, so the area is the same as those you're supposed to be, okay? And they're shorter, so the curves to the left, right? You guys got it. All right. So I'm gonna have you guys, well, here, I'll show you guys what we're about to do. I need some measurements. Now, again, I listed some measurements for these different populations, but we're gonna get your guys' heights. And I'll show you guys what we'll do with them. We're gonna get the mean. So I'll just call it X bar, right? Is the mean. Right. And you know what that is you add up all the values. So I'll do X sub I, and you guys know the sigma is summation, like you add them all up, and then divide by the number in set. Right? You guys have done that probably before you ever walked in this class. You guys can do that. Okay. Now the one that's probably new to most of you guys, if you've never had stats, is the standard deviation. So standard deviation. Oh, here, I'll put the other, I'll say mu or X bar, I'll use sigma or S. I see those. Okay. Now this one, there's a whole process, and it's going to go like this. You take each individual value, so that's X sub I, which there will be 5 different values, right? Because there's 5 different students in here. Okay. You subtract the average, because there will be some average for average height here. Okay. Okay. Now, let me throw a little trick in here. If you've been through stats, then you'll know this is sort of a mistake, but I'll round back around to this. Okay. Guys, if I added up all the differences, there would be 5 differences, right? So each one of you has a difference from the mean. Some of you are taller than the average in the class, some of you are shorter than the average in the class. If you added all those up, what number would it necessarily have to come out to at this point?
100.
How about 0? 0. Because if some of you are like 2 centimeters over, some of you are 2 centimeters under, then wouldn't that be a wash and it would just go to 0? Okay. So if I did this, it would just be 0, and that would be completely pointless because there could be no information we could ever get from that. Okay. So before we do summation, I'm going to have you actually square all the differences, right? And then add up all the differences. Okay. Now, after that, we're going to divide by the number in the class minus 1, since there's 5 of you guys, 5 minus 1 would be 4. This has to do with something called degrees of freedom. I'm not going to get into that, but it's just what you do for standard deviation. The last step is we're going to take the square root of this whole process. Right? When you do that, remember what that represents. That represents this distance from the mean to the inflection point on the bell curve, which means you create a whole bell curve out of this. Right? So just from 5 students, now, and this is another simplification is realistically, like if you are a statistician or data scientist or something one day, you would really want maybe a sample size of at least hundreds, maybe 1,000 or more. Right? We just have 5, so we're going to make believe that we can actually get some information out of this. Okay, but I'm going to pause this video and give you guys a couple of minutes to get your heights, and then I'll show you guys how to crunch the data. All right, got recorded back going. So these are guys' heights. All right, so let's do both these formulas. Here, I'll just do the mean on the calculator. Can you guys follow along with me? Because you guys have probably done this lots of times before. So open parentheses to the first height plus the second height, third height, fourth height, fifth height, then close parentheses, then divide by 5 because there's 5 of you guys. Right? And I'm getting, I'll call it X bar for average, 172.8, and that's centimeters. Right? You guys know in this class, numbers have units attached to them. Talk about centimeters here. Right? Right. You guys get the same thing? Did I type that right? Okay, so okay. Okay. Now the standard deviation. You guys see this is going to be a longer process. Right, so get an extra paper for this. Okay. So well, I'll tell you what. Let's just do it. Let's do this full process. All right, you guys ready to do this with me? Okay, this is practicing. Right, so I'll start with this individual value, and there are 5 of them. I'm going to subtract the average, right, and then square that, and I'll do that for all 5. Right, so I got 163. These are all centimeters. Okay, minus 172.8. I'm going to square that. Okay, and remember it's summation, so I'm going to say plus, and I'll do this for the other 4. Just going down the line. All right, so 75 minus 172.8. Square that. Well, you guys know these are all centimeters, right? right? Okay. When I got all the differences squared and then added up, we're gonna take that and divide by, since there's five of you guys, 5 - 1 would give you 4. And then the last step is to take the square root of this whole process. Okay. So that's standard deviation equals, right? So let's see what we get from that. So you guys do it, I'll do it, and let's see if we get the same result. Because it's easy to make mistakes, so we're all each other on track here. Is that also in here? Yeah, I think so. I like that, right? Okay, I'm getting a number out of this. Right. Oh, this would also be in centimeters because that's, I think it was kind of like a plus or minus value. Okay, so I'm getting that. Did you guys get to an answer by now? Oh, okay, so still getting there. No. Okay. Hey guys, I'll finish that calculation. Get you one of these Z tables right here. Yep. How about now? You guys getting what I got? Right. Yeah. Oh, all right. Here, have a Z table. Z table. Okay, yeah, all right, so you get the same thing I got?
That is not what I got.
Oh, no?
Uh,
You know what? All right, so one of us made a mistake. Here, let me show you guys the fast way to do this. You guys want to see the way that the calculator can crunch all that data for you?
Sure.
Okay, the important thing here is that you guys see that there is a process, like how to get that. All right, so here we go. So make sure you have this model calculator. Does everybody have this model? All right. All right, so everybody has the TI-30X2S, basically got this. Okay. Now, do you guys see above the cosine key, there's a key that says data? Do you guys see that? Right. And right above that, probably in white letters, mine is blue letters, it says stat. You guys see stat? And you access that by hitting the second key. So everybody hit second in stat. Right, second stat. And it should pop up one variable. Do you guys see one variable? So click enter. So you have one variable. Okay. And the word stat pops up on the screen. Everybody's got the word stat on the screen? You guys got that? Here, make sure. Let's see. Okay. Okay. So, oh, yours has stat. Ready to go. Right, got it. Now that one I don't know, but that one I do. Okay, got stat, got stat. You guys got stat. Yeah, you guys can have this. All right. So now the calculator's programmed to accept data to crunch stat for you. Okay, now hit the key that says data. I mean, it's the same key, it's just data now. Okay, and it should say X1. Okay, guys, who does not have X1 on their screen? Everybody's got X1? Okay, now we're gonna plug in the data, and here's your 5 data. These are your guys' heights. This is what you guys just measured. We're gonna plug these in. So the first one's 163. So type in 163. Okay, then scroll down. It says frequency 1. Well, there's only one person with that height, so we're good to go. Now, could you imagine if you were doing real stats in the field, there might be like 22 of these or something, you could just type 22 or something, but there's only one. So I'm gonna scroll down again, and now I've got X2 up. And the second height is this height right here, 175. Scroll down, frequency 1, yep. Scroll down again, X3. Type in the third height, scroll, scroll. Type in the fourth height, scroll, scroll. Type in the fifth height, okay? Now the 5 heights are in the calculator. Okay, you guys got the 5 heights in the calculator? Okay. Now, to the right of the data key, see it says stat var. You guys see stat var right there? Click that key, stat var. Point. Okay, and it'll crunch all the numbers for you. N equals 5. Yep, because there's 5 data points. Right? Right. So 5 data points. Scroll to the right. X bar. Hey, look at that. It's the mean. It's the same thing we got before. Remember the 172.8 centimeters? But which, again, you guys probably knew how to do before you ever walked in this class back in August. Okay, just add them all up, divide by the number, in this case 5, right? But did it for you. Now, if we scroll to the right again, you guys see S right there for standard deviation? There it is, 5.89. That, you did that whole process for you right there. That whole process. It again, tells you like how wide is the bell curve, the distance from the mean to that inflection point. That's it. So I'll write that down right here. I'll do S for standard deviation. I'll do 5.89. Now it's also centimeters. Okay.
I got that right. I just forgot the square root.
Ah, okay. Yeah, okay. So we're all good then. We're all good. Yeah. By the way, I think if you don't square root it, there's a term, I think you call it variance. I've taken stats a long time, so I forget what like Y or what that's about. That means something. Yeah. So standard deviation. There we go. So now that 5.89 centimeters. You see that's effectively like a plus or minus value. So if you take the average height, like 172.8 centimeters, you plus or minus 5.89 centimeters, it covers.
66.
Oh, close. It's like, yeah.
It's something that I don't
Close.
forget these.
60, it's like 68%, 68%. Yeah. There's something called the, if you ever take stats, you're gonna see this. It's called the 68, 95, 99, 7 rule, right? So that's plus or minus 1 standard deviation, plus or minus 2, and plus or minus 3 standard deviation. Maybe plus or minus 3 standard deviations, 99.7% of the whole population, like that's almost everything. Right? At that point, the tails are extremely tiny, right? But yeah, okay, so I could say, if this data is somehow representative of the entire school, I could say this middle height plus or minus this 5 or 6 centimeters should cover about 2/3 of the entire school, right? And we got, again, on this tail, that about 1 and 6 are way taller than that, and about 1 and 6 are way shorter than that. That's about it, right? Right. So you guys good so far? Right. So going down my list here. Next, we're working up towards this pair of questions at the end, like where do you sort of rank within the school? But to be able to answer that, we got to talk about Z-score and Z-table. So Z-score, here, I'll sort of spell this out for you guys. Z-score is a count of how many standard deviations from the mean an individual is. Right. So, for example, here just to be real simple, right? If you were 1 standard deviation above the mean in terms of height, you say, okay, well, I know the mean's like 172.8. If I'm 1 standard deviation above that, I'll add 5.89, right? And that would be however many centimeters that is, about what?
Isn't that calculus finding it under the curve?
There's that calculus connection here. Yes, it's something about like Gaussian distribution, if you want to Google that term, something like that, to make this bell curve. Here, I'll jot that down too. It's called Gaussian distribution, something like that. Right? No, normal distribution bell curve. Okay. Right. So, and there's a formula to get this. Like, if you know what this means, if you internalize it, you can probably figure out how this goes. And it goes like this. Take your individual value, your individual height. Again, there's 5 of you, so any of these numbers could go there. Subtract the mean, which we found is here. Okay, so that tells you right away, are you above or below average, whether it's positive or negative? Because if you were short, this would be negative, wouldn't it? Right? But then remember what we're trying to do, we're trying to get a count of how many standard deviations. So you divide by the standard deviation size. That gives you a count of how many standard deviations. So if you were 1 standard deviation above the mean, then the numerator would be like 5.89. The standard deviation itself was 5.89. You see that would divide out to 1 as a 1 standard deviation above the mean. Right. So let's try this. I'm gonna pick one of you guys randomly. Let's say the 163 centimeters. Now you just for your own height too. Just right. So I'm gonna take the 163 centimeter person. Right. I'll subtract the mean, which was just right here. Remember 172.8. It's also centimeters. Right. Okay. And then compared to what? Like, are you extremely tall or short, or you're just a little bit taller or short? Well, that depends on standard deviation size. So do 5.89 centimeters right here. We're going to get a z-score for this person. All right, so let's see. Whoops. All right, so here's 163, 172.8 divided by 589. Right. So, okay, I'm getting this z-score. Okay. Now, notice that it's negative. That just means like a below average value. So this would be one of the short people. In fact, actually, it looks like I picked the shortest person on the entire list, right? So it had to have come out negative, right? If you're the right. And if you're the tallest person on this list, then it has to come out positive. But it's probably somewhere between -3 and 3. Did everybody get for their own z-score somewhere between -3 and 3? If you did, you probably did it right. Okay. Right. Now we're ready for the z table. Right. You guys ready for this? Now, well. Here's the version I was given my other classes where they have 2 halves of this table and it all fit on 1 page. It's just really tiny font. Now you guys think, well, it's 1 class. We don't want you guys to show up here. So I printed out big so it's easier to see. Okay. But really there's a left half and a right half of the table. It's just on opposite side. Okay. Now on one side of your paper, whoops. Sorry, there we go. Right. On one side of your paper, do you guys see just a little tail shaded on the left side, right? And all of the z-scores are negative. Right? And then on the other side of your page, there's most of the bell curve is shaded in. Still the left side, but it's like most of it shaded in. And notice all the z-scores are positive. It starts at 0 and then it goes positive. Okay. And between the 2 halves of this table, do you guys see the smallest z-score is like -3.5 about, and the biggest is 3.5? Okay. Now you can go more granular if you go across the top. See, it's 0.00, 0.01, 0.02, all the way to 0.09. So if you wanted to say -3.49, here's -3.4 and 9, and it tells you this right here. Okay. Now the numbers in the table. Wait, is there a question so far about how to get z-score? Okay. Right. So actually, I have a z-score because we just found one here. I got -1.66. Notice this is unitless because it's centimeters over centimeters. Just remember, it's a count of how many standard deviations. So -1.66. What would this mean? Again, this is for anything that's normally distributed. You can use the z table. So I'll go to -1.6012345 That's right here. Okay. Now, what this tells me is how much of this bell curve is shaded up to that value. Right? You guys get that? Okay. Now it says a decimal, but can you guys go from decimal to percent? You just very simply multiply by what? 100, right? 100, right? So if this is 0.0485, could that be like 4.85%? Is it okay if I round that a little bit to 5%? 5%, is that okay? Okay. So even though within this class, the 163 centimeter tall person could be considered the shortest person, if I say, well, for the entire school, suppose you guys were representative of the entire school, could there be anybody shorter than you? It's like, well, yeah, statistically, probably, but how many? And the z table says that the answer to that is approximately 5%. So we would say about right here, point. About 5% of people would be shorter than the shortest person in the class, and 95% would be taller, because those were the 2 questions we were laid out to, right? How many are shorter? How many taller? Right? Because if 5% are shorter, does it make sense the other 95% would be taller? Right? you know, if you're the only person to your height, okay? Here, I'm gonna do one more with you guys. So here, I'll just pick, how about kind of an average person? You see this once, no, let me do this a little bit taller than average. How about 175? About 175, let's try that, because that'd be positive, but just a little bit positive. Let's play this out. So I'm gonna take, and I got another page for this. Okay. Let's find z-score for the 175 centimeter person. Would be 175 centimeters. Subtract the mean, which is 172.8 centimeters. Right? Now, already I see a positive value. That means this person's a little taller than average, but how much taller? We're talking about like one of the tallest people ever. Are we talking about just a little bit taller than average? Okay? You can only know that if you divide by the standard deviation to effectively get a count of how many standard deviations above the mean this individual is. So that minus that, close parenthesis, divide by that. Okay, I'm getting, okay, yeah, it's a small positive z-score, 0.37. Okay, so what does that mean? Okay, well, I can't use the negative z-score half the table, so I'm going to go to the positive z-score. Oh, by the way, do you guys see if you have a z-score of 0, that means you're 0 standard deviations from the mean? Does that mean you're exactly average? Does that mean that half the bell curve exactly would be filled up? And that's exactly what this says right here, 0.50. Okay. This is 3209. Yeah, all right. All right, but let's, okay, you guys do see that, right? All right.
So it's the average minus the height you're trying to do divided by the standard deviation.
Yeah, so take your height, subtract the average, right, and divide by the standard deviation. They'll tell you your z-score, right? Right. Again, this normal distribution could be anything that's normally distributed. Right? It could be like, what's the blood pressure of giraffes or something, and you can sample like 1,000 giraffes and probably make a bell curve. Right? What's the body temperature of people, and probably makes a skinny bell curve, right? Because we're all about 98.6 degrees Fahrenheit. Yeah, but plus or minus a degree or so. Not everybody's exactly that. It might depend on the day, right? Right, so let's do 0.37. So 0.3 and then 7 is way over here. So it says 0.64. Is that like 64%? 64%? Okay, so what that means is that this particular person is taller than 64% of people in the school. And that would make them shorter than what? 36, I think, percent, right? Yeah, so a little taller than average, but not crazy taller than average, right? Sort of average-ish. I guess that. Right, and there's okay, this is just the intro to stats. So hopefully you guys do take a stats class one day, because this is one of these classes that definitely changed my view of the world. There's all kinds of cool stuff you can do with this, and if you're going into like hard science and doing scientific experiment stuff, there's probably going to be a stats application somewhere in there. Right? But this could be a real good intro, and then when you guys see these concepts one day in a stats class, it'll make it that much easier to pick up, and then you can learn lots of other cool stuff you can do with it.